All right, we only got 57 clickers. Everyone pile on. Just vote anything you want. I don't care. 64. Okay, so before I explain what is going on right now, firstly, everyone, thank you so much for filling out FCQs. Scores are in. They were awesome scores. I really appreciate it. I really appreciated everyone who actually wrote down comments. The most common constructive criticism was sometimes you go way too fast. So I was thinking about this on Wednesday, and I'm an engineer, so I had to find an engineering solution to this, of course. So we're going to try a new use of clickers. You guys have to let me know how this goes. This will be up the entire time as we go through this review. Vote honestly, but vote real time. And if it starts going too fast, I'll slow down. If it's too slow, I'll speed up. So that's what's going on here. So ideally, everyone stay on C, and then depending on how you feel and what's going on, move up or down. So today we're just going to go over classes. There was such a strong vote for classes on Wednesday that I figured we'll just do the entire thing classes today. And then next week, Professor Osborne can start going over some pointer stuff. You guys want some of that? All right, let's get started. So before we get started, are there any questions? Everyone's good? Yeah? Sorry?
Are pointers on the Monday?
Oh, I actually have no idea. I haven't looked at it. Sorry. You have to ask Professor Osborne about that. Okay, so let's go back to the beginning with classes. Let's go back to C. C didn't have classes. They had what's called structs, which are similar to classes. But remember I was saying that they have just data in them. They've got nothing in them but data. They're just kind of a grouping of data. So I figured I'd stop beating the dead horse with the blueprint house analogy, because maybe it's just not clicking for everyone, and try a different analogy. So what we're going to go with this time is databases. You don't even know anything about databases. We're not learning databases. I'm just going to use them as an analogy for classes. And to start with structs. So we're going to be going over programming terminology and then database terminology. As far as what they both have in common, they both define what each instance has in it, what data types it has in it, and what those data types are called. So let's get started. A database, I don't know if you guys have ever looked at a database, it's fine if you haven't, but when you create a table in a database, you have to create what's called a schema. And that strictly defines what rows can be put into this database. So this particular schema has a name, which must be a string. It's got an age, which must be an int, and a GPA, which must be a float. And every single entry into this table must follow those exact parameters. Now in programming land, if we go back to structs, this looks like this. You declare a struct. I'm going to call it person. And this, by the way, is the person table. So that's the analogy to this. And it's got three different chunks of data in it. A name, a char star, which is the C gross version of a string, remember. Int age and a float GPA. So these two are very similar. So now let's get into instantiation, which in database land, you could call it creating a row or inserting a row or something like that. In database land, if it's the right database, you can actually create a row that's just got garbage in it. It's actually got nulls in it. It's just non-initialized. It's just a row that sits there, and it's just got junk in it. You can do the exact same thing in code, of course. I can say person Alec, person Stephen. Both of those exist in memory, but at this current point in time, they're filled with garbage, just like this. Here's Alec, it's a row named Alec, and by the way, rows in databases are not actually named. I just chose to name it because that's what it looks like in code. And then you've got the ability to set a single entry in a database. So first you can say, for the Alec row, I want to set the name column, which, I said two things there. There's the Alec, so that's the entire row here. And then there's the name column, and it's a string. And I can set that equal to something. Set it equal to the string Alec 20. Likewise, in programming, you've got a struct, an instance of a struct, called Alec. It's an instance of the struct type person, and then you use the dot notation to get at a member of it. And remember, if this isn't making sense, vote on clickers. Or if we're going too slow, vote on clickers. I see some of you guys kind of clickers. Looks like it's still working on people. So you'll notice I've got two things here. Just like in the database, I have to specify the row and I have to specify the column. I've done both those here. Here's the row, here's the column. I've got the two chunks of data that I need to access this unique cell. Now the big difference between an instance in programming land and a row in a database is that they don't necessarily live next to each other, programming instances. So I can create multiple persons in C, and they could live in like totally different parts of the memory. It's totally fine to do. And they all have to be named. Okay, so moving on. This is the exact same code, except I'm just setting all the other cells here. So first I'm going through and setting Alec, and I am apparently failing out of college. And then the rest of the code is just chopped off for not making a giant slide here. But I also added in Stephen Hawking, whose GPA is over 9,000. If anyone gets that joke. Apparently a lot of you do. Nice. I was concerned about that one. Okay, so I figured we'd also go over a little bit of functions. First, just regular functions, and then how they apply to classes. When they're in a class, they're called a member function. Remember that. There's a lot of confusion on the last homework about this, so I figured we'd go over this visually. So first thing I want to do is make a function called toString. And the toString function, its sole responsibility is going to be taking in a struct, a person struct, and then constructing a nice, prettily formatted, I don't think that's a word, formatted string that I can do whatever I want. Spit out to console, store somewhere, whatever I want to do with it. So a function has a bunch of inputs. Right now it's only got one input, a pointer to a person. And then it always, in C++, it always has an output. The output can be void, but it always has an output. So this green box is your output. This function is going to spit out an std string, and it's going to take in a pointer to a person. How does everyone feel with that one? Good? A little confusion? Yeah?
Why is that to take in a pointer instead of just taking in person?
Because I wanted to go over a little bit of pointers too. It could just take in a person, but remember, if we go back to what this looks like, it has a char star in there, name. So when you copy a person, all you're going to copy is the pointer to that character string. So if one person mutilates that string because they have, so for example, if I say person Alec and create an Alec, and then I say person Stephen equals Alec, it's going to make a copy of Alec, right? But when it copies this name, all it's going to do is copy the pointer to that chunk of memory where the actual string exists. So if one of those two changes names, either Alec or Stephen, it's actually going to change the name for both of them. They're both pointing to the same string. So that's why I chose to use a pointer, to make it clear that I intend to be pointing to the same object. I'm being explicit about this. I want you to be pointing to the same object. And it's actually much more efficient to pass them to that point. And it's usually done that way. So back to this. This diagram here, the entire thing is a string. Oh god, that didn't make sense to you guys, did it? So for now, just know that I'm passing this by pointer, because it's a little bit, for now I just chose to do it that way. So I'm going to pass something into this function by pointer because I want to do by pointers. And when we go over pointers, we can look at exactly why I chose to do that. But let's go back over this and just look at this specific function, right? This whole thing here is a function called toString. A function always has inputs, and in C++ it always has an output. And remember, I said to think of functions like a big black box, right? You don't know what's in the big black box. You don't know how it does what it does. All you know is what it takes in, and then what it spits out. That's it. And you can read the documentation to see what this function is supposed to do. It's supposed to be a completely black box that's totally opaque. You can't see what's going on. So that's how I've drawn this. There's this big line. Everything within this line is only visible to the function. Everything on the border of it is actually visible to both. So that's kind of your middle ground between going in and out of the box. So what's the problem with this? If you're within this function, how do you address this person star? That's where parameters come in, right? When you're writing a function, you say void foo, open parenthesis, int, and then whatever you want to name that int. We'll name it bar, close parenthesis. The bar, the name that you just assigned to that int, is called a parameter. It's only accessible within the function. There's a lot of confusion on this with the homework. So I've chosen to name my parameter this person. I can only use the name this person within the function. Now the actual value itself is of course accessible without outside of the function, because someone needs to be able to pass in something to the function. It can't be like in its own black box so the function would be useless. It would take nothing in. But the name itself is only visible within the function. Yeah? Yeah, I did. That's why it's person star, this person. So the full type, if you were to look at the C++ code, would be std string, and then the name toString, open parenthesis, and then person star, this person, close parenthesis. Hopefully I wrote that down somewhere. If not, we can look at that in code. We're going to look at some of this in code too. Other questions? For anyone who's on D here, or E? No? Okay, so we've now got two things going on here. We've got main, which is our entry point to the program. This program's just got two functions. It's got main and it's got toString right now. We're running through main. There's code in main. I didn't show it here. But I have two chunks of data in main right now. Although I could have more. So if we look at this function, there's two things that this function is going to need to be called. The first is a pointer to a person. That's what you need to pass into the function. The other thing that's less obvious is somewhere to save the results. Now you'll notice the results here are not named. The return type of a function is never named. It's just std string and then the name of the function. I never assigned a name to it. And that's why you say return and then the value within the function. It gets assigned to this little blue box. And this little blue box, there's always one of them. There will always be exactly one, so you don't need to name it because it's understood that there's always one. So I made another string here, which is what I'm going to use to save the results. So after I've called, while I'm calling toString, this is what it looks like. This would be what the code would look like to call it. So here's my function call, toString, open parenthesis. That tells you this is a function call, right? This is a function, and I wish to call it. And then I've got Stephen. But remember from the previous slide, Stephen just sits right there. It's not a pointer to Stephen, the actual object. I just said person Stephen. So Stephen A sits on the stack, and B, it's not a pointer, it's an actual object. But what this function's expecting is a pointer to an object, right? So I have to use the address of operator, ampersand. And what that actually does, under the covers, is it creates a temporary little variable that just so happens to have the address of where Stephen lives in memory. And then it passes that into the function. That's actually what gets handed in the function. Yep?
So the only time that you reference it is if it's pointing to like a pointer. The only time that you would use ampersand Stephen is if person star was there?
Right, exactly. No, you wouldn't use it if person star was there. So what this function is expecting in is a pointer to a person, right? Yeah. So if I just hand it a whole person, it's going to be like, that's not what I asked for. And C++, it's just not going to compile it with a compiler. What it's asking for is a pointer to where a person lives somewhere in memory. Now I have a person. Let's say here's my person, right? I made this, it's in main. We'll look at this code, it's in main. Now I need to get a pointer to this because that's what the function's expecting. So I use the address of operator. Now I've got a pointer to my person. Now I can pass this into the function because this is what it's expecting. And C++ does that automatically for you, just with the ampersand. It actually is going to create a little unnamed variable somewhere. It's going to put the address of my person right here in it. Then it's going to pass that off to the function. Yeah?
So you're talking the address of Stephen. So you get so that the function gets access to the actual value of Stephen's person.
Yeah.
And if you're making changes to the function, then that is changing to the entire program, right?
Yeah. Yeah, so the question was, if I change something within the toString, if I were to change something within Stephen, it would change it for the entire program, right? And the answer is yes.
The name
because I have a pointer to the actual person, if I change anything, it's going to change it throughout the run of the entire program. Yep?
Functions expect a pointer to an object, but is it the ampersand an address of the object? So why is it not like asterisk Stephen instead of ampersand Stephen?
Don't confuse pointers with addresses. They're basically the exact same thing. Don't think of them different. What the function's expecting in is the address of, or the pointer to, a person. So if I have an entire person, I need to use the address of to first get a pointer, which is just an integer value that has the address of a person in it. And that's what gets passed in. I hope that answers your question. And then lastly, I'm going to actually assign this std string that's returned from the function to an actual variable. And I named it Stephen Stir, which this is the code, this is what it would look like to run, right? Stephen Stir equals, and then invoke the function, pass my parameters. Yeah?
Does Stephen need to be previously defined before you call it to within that function?
Yeah, in this case right here, both of these have to be previously defined. They both have to be std. The Stephen Stir needs to be std stir, Stephen Stir somewhere, and then there needs to be a person Stephen somewhere in code above. Okay, let's code that up real quick. See what that looks like. So I've already created the person struct here. And I've already created two structs, two struct instances right here. And then I've just assigned their values. This is all really basic code. And you guys will notice this is not a class, this is a struct, right? All it's gotten is data. Nothing else in it. Now let's just code up that toString real quick. So we're going to take in a person star, a pointer to a person, and I named it this person. Now we're just going to return. Okay, how many of you, by show of hands, know what that arrow is right there that I just highlighted? None of you? Really? Oh, okay. Good. This is something that I can't believe was not going to work earlier. Okay, so I've got a pointer to a person right now, right? And if I want to get to a value within the actual person itself, I use the dereference operator, right? So here I have a pointer to a person. I don't want to get something from the pointer itself. I want to get something from the person itself. I want to get the person's name, or their age, or their GPA. So the first thing that I need to do is say, pointer, I don't want you to be a pointer anymore. I'm going to dereference you. I want you to jump through one of your hoops. Voila, now he's a person. Hopefully I don't trick doing that. That'll be really amusing. So now, once I've dereferenced it, I'm going to put parentheses around this to make it real clear what's going on. So I've dereferenced this pointer. Now I can do dot, right? Now I can access something within this person, because I'm an actual person now. I've dereferenced it. So now I can say something like dot name. And I've got a hold of the actual name. The blue is going up here. Now the orange is going up. Yeah?
Is the significance of the parentheses just to show that asterisk this person things that you want to apply to documents?
Yeah, I'm pretty sure they're actually required unless they've changed this. But last time I checked, if you do this, C++ is really dumb, and it's going to try to do what's highlighted first and then dereference it. So you have to put in the parentheses to say, please, I need you to dereference this pointer first. Then I need you to access a member within this object. Where are points of confusion on this? Is it the pointer part or is it the dot part? The pointer part? Okay, so when you're within a function, when you're within the code of a function, this is really important. You don't care what exists outside of your function. You can't access it, you don't care about it, it's irrelevant. So when you're within this function, the only thing that exists to you right now is the variable this person. And I know that it's a pointer to an object, which is an instance of a person. Remember, it's just like the databases, right? I'm pointing to a row in a database somewhere. I know exactly what's going to be in that row by type. I know it's going to have a name. I know it's going to have an age. I know it's going to have a GPA. I don't know what the values are, That's the whole point of passing these things around. They were all identical, there'd be no point. So I'm pointing to a row in a database somewhere, or in programming land, an object in memory somewhere. I'm a pointer. I don't want to get the name of the pointer. The pointer doesn't have a name. It's just an integer. That doesn't even make sense to say. What I want is to say, the thing this points to, I need you to actually go to what it points to, and I want to access the field called name in there. That's the dot notation. So think of this in two parts. First, you're getting rid of the pointer, and you're getting an actual person. Then, when you have the actual person, you're saying, now I need you to give me the name, or I need you to give me the GPA, or the age. Yeah?
Just, sorry, stepping back a moment to confirm as well. So when you're defining this function, what you're basically saying is person star is going to take the pointer, and then this person just says, I'm going to call it this person in the context of this definition. I'm going to call the whatever I'm manipulating.
Sorry, say that once more?
All right, I guess really the question is just trying to understand the syntax of having to put person star and then this person and what the relevance of saying what the pointer is and then giving some kind of variable after it.
For this line? Or the significance of passing it in right here by pointer?
That's right.
Yeah? So you guys remember when you did your homework and you had this, and that's how you passed everything around? It was like int, and then the ampersand symbol, and then meters, or I guess feet, and then inches, and then meters with a float. This is a different data type. When you put this little ampersand here, it means it's a different data type than just saying something like this. If I say person, this person, what this function is expecting in is an entire copy of a person object. All of it. I want the name copied, I want the age copied, and I want the GPA copied. I want my own personal copy. When I say int person ampersand, like this, like what you guys were doing on homework, I'm saying, compiler, I want you to give me a pointer to a person, but I don't want to deal with pointers right now. So just do it for me. And understand that what I'm asking you for is a pointer to a person, but I don't feel like thinking about pointers. And then if I do this, I'm just being explicit. It's the exact same thing. I'm still saying I want a pointer to a person somewhere. But now I'm going to be explicit, and I'll do the pointer stuff for you. Yeah?
Is that different than getting rid of the asterisk after person and the asterisk before this person?
No.
It's the same thing.
No, they're totally different. Because what I'm saying right here is I want a full copy.
Then later on, when you say this person got name, you got rid of that asterisk.
Oh yeah, it would compile. It would work just fine. You're now just making a copy of the person. So I guess we are going to be going over more pointers today than was expected. Yeah?
Why don't you want the copy?
Why don't you want the copy?
Yeah.
There's a few reasons. One is some objects don't make sense to copy. For example, when you open a file, it doesn't really make sense to copy the handle to the file, even though you actually can do that, but that's implemented in completely different ways. You actually want the same file. You want a pointer to the same file. Or, and we'll look at this later, what if my function is supposed to change something in the person? I want it to reach in there and change a name. I've actually got a function later on in the slides called time warp, and it adds on n to the age of the person. If I passed in a copy of the person, it would add on the n to the age of the copy, and then the function would finish running, and then that's it. It would just destroy all the changes that we just made, because it made it in its own personal copy. So a big use case is, what if I want to change something in the struct? Right? It's the only way to do it, is to pass in a pointer to where it exists in memory. And it's also much, much, much more efficient to pass in a pointer. A pointer is really easy to make. Copying an entire object is not. It can be expensive. But I wouldn't worry about stuff like that, because it's all going to be just stupid fast compared to Python anyway. So let's go back to pointers, and let's put this code back how it's supposed to be. So I've dereferenced the pointer. I've now got a hold of an actual physical object here. And then I'm going to use my dot notation right there. Say dot, and then access the name field in it. Now, let's delete this line. Oh, yeah, we'll do this too. Okay, so I was going over what that arrow was, right? You're going to see this everywhere in C++. This is like the biggest operator used in C++. You see this right here, where I had to put parentheses around it, and then dereference it, and then use the dot operation? This is done all the time, because passing things by pointers is really, really, really common in C++. It's how most code runs, right? So they got rid of this and they just made a shorthand. It does the exact same thing for this. The line of code that I just deleted and this do the exact same thing. First, it dereferences this pointer until it has a hold of an object, and then it accesses a member within that object, in this case called name. So I'll write the other line of code in comments just so you can see it. Oops, not like that. So these two do the exact same thing, with the exception of the return statement. These two are identical. They compile the same code, they do the exact same thing. You could get away with just using the top one forever, you'd be fine. It's just ugly, nobody wants to do it. So we created this nice little arrow here. So back to my function, before we get too sidetracked. And you don't need to worry about what toString does. It's just so I can make this work. Let's do age. And then let's do... Okay, so this function just returns a string that's composed of first the name, followed by the age, followed by the GPA, and all separated by commas, just so it's easy to read. You guys don't need to worry about what std2string does. It's not part of this. It's just so I can make this compile. So now, if I were to come down here, I could actually say something like Stephen, I could say something like toString, and then I could pass in a pointer to Stephen. Now this will compile, but if I run this, of course it won't do anything. It won't print anything. It prints out nothing, right? Because toString here returns a string. It doesn't automatically print it to the console for you. It's just going to build you a nice pretty string and then it's going to return it to you. So now what I need to do is save that somewhere. I think in the last slide I called it Stephen Stir. So now I've saved that string somewhere. Now I can just see out it. Now if I run this, there it is. Stephen Hawking, 73 years old. I can't believe he's 73 years old. And super smart guy, apparently. How's that sitting with everyone? Yep.
You wouldn't be able to just see out toString parentheses.
You could. Yeah. Yeah, you absolutely could. So what she asked was if you just do this. Oops. So both of these will print the exact same thing. The reason I chose not to do this is because you guys learned in Python, you guys get really easily confused between the difference between printing and returning. A lot of you have that really muddied in your mind, so I'm trying to keep those two concepts very distinct. They're very separate things. Printing to a console is very different and completely unrelated to returning. Oops, it's not like it. All right, we must persevere. Okay, so next thing we're going to do is write another function. It's very similar to the last function in that it takes in a person star. This one, however, is going to return a void, aka nothing. But the green box is still there. I still have to say I'm returning nothing. There is still exactly one return type, and that's a void. It's also going to take in an int. Now, because it's not an int star, this is an actual copy of an integer. So I'm just taking in a copy. Okay, I'm going to code that up super, super fast. I'm having trouble typing today. Person, int, let's call it n. And all it's going to do is this person, arrow. So remember, I still have a pointer, so I still have to dereference this person. I'm going to access their age, and I'm going to plus equals n to it. You guys have all seen plus equals, right, in Python? It's the exact same thing as this person arrow age equals this person arrow age plus n. Does the same thing. Cool. So now I could use that. We could use that right here. I could say time warp domain. I still need to use the ampersand because I still need to pass in a pointer. And now I can say, let's make him 5 years old. And now if I run this, you can see he just advanced 5 years. Now, you'll notice something about these two functions. And this was the motivation for C++. What do they both have? They both take in a pointer to a person. You cannot run these functions without a person in memory somewhere. It doesn't make logical sense to say toString and then a person that doesn't exist. That doesn't make any sense to say. You must have an object in memory to get them to print out their information neatly. So this was the motivation behind C++. And what they did is create classes. And classes are just like structs. They still hold data, just like we saw before. But now they can also hold a set of functions that are called member functions. And member functions have a little hidden parameter here that's a pointer to the thing they're a member of. These are added in automatically for you. So you don't even see them. You don't see them when you're declaring a member function, but they're there. It's the first parameter there. It's a pointer to the object itself. Yeah?
So you can use documentation.
Yeah, exactly. So we'll look at that in code in just a second. So now if we look at, remembering that we can't see these grayed out things here that the arrows are pointing to, if we look at the signature, the declaration of these two functions, this is a function called toString. It returns an std string, and it takes in nothing. It has 0 parameters. This one takes in an integer, and it returns a void. That's all it takes in, it's just a single integer. So let's go back to database land and look at what this could look like. There isn't really a direct analogy to this in databases, so I'm kind of stretching here. So our database has 3 fields in it, right? Name, age, and GPA. One's a string, one's an int, one's a float. And this is what it looks like for a struct. Now let's move that over to classes. We've got the exact same 3 chunks of data here. Here they are right here. Char star name, int age, float GPA. Now it's a class. Now it's capable of holding member functions. Now if you compile a struct on C++, it turns out you can throw member functions in there freely. There's pretty much no difference between a struct and a class in C++, but in C you cannot do this. C won't let you do this. Now the database, it's got these 3 columns in it, right? I've also added in these 2 things off to the side that it's capable to doing, it can do one of these to a single row. Now there's not really an analogy for this in databases because you never really want to do something to a single row. You want to do something to all the rows. So let's pretend like this. So I can say toString of a single row or time warp of a single row. And this is what that looks like in C++. So here's my class. Notice the open squiggly brace and then the closed squiggly brace. These 2 functions are declared within the class, automatically and magically making them member functions. Which means, remember back to here, they've got these. They're built in. They're hidden, but they're built in. It's the exact same 2 functions, toString, time warp. So what I can do here, if I scroll up, and I first make this a class, I can now take these 2 functions here, and I can put them right here. Let's, oops, oh god, what's going on? Let's indent these so I can actually read it. And now what we can do is get rid of these pointers. Remember the first thing I had to pass into these functions was a pointer to a person? This is now done automatically for me. So I can get rid of this, and I can get rid of this. Now it's going to complain saying, I don't know what this person is. Let's look back at the slides and take a look at this right here. What does C++ automatically name these pointers? It names them this. That's a reserved keyword. Think of it just like a parameter type, a parameter name, but it's reserved. You can't use it anywhere else. So what I'm going to do is just use this, and notice that it just changed colors because it's reserved. And then I can do that here too, and then here too. Now this function will compile. Let's fix this one. Voila, build. We're going to have build failures because our main is now wrong. But now we have 2 member functions. Now how do we use these 2 member functions? Remember the dot notation. Oh, yes, and I skipped this on slides. So the only difference, by the way, in C++ between a struct and a class is a struct, everything's automatically public. In a class, everything's automatically private. So you have to put in public colon. I'm just going to leave everything public for now, even though that's probably bad practice, because I don't feel like dealing with that stuff right now. So rather than calling toString and passing in a pointer to Stephen, what I'm going to do now is I'm going to say Stephen dot toString. This thing takes in no arguments. The difference between an argument and a parameter is which side of the black box of the function you're on. An argument is if you're on the outside, and a parameter is if you're on the inside. Just FYI. I think there was a question about that on the middle. So I have a pointer here. I have an object here called Stephen, and I'm going to call toString on it. C++ is going to automatically get the pointer to that object for me, and it's going to pass it into this little hidden parameter on that function toString. Okay, and then I can do the exact same thing with this. Let's just flip that over. Save time warp, and now it takes in only a single argument. I'll pass in 5 years. And then I need to fix this as well. And now this will run. And it produces the exact same thing. Thank goodness. So that seems like a lot to take in. And this example itself, because it's so little code, it doesn't seem very useful. But what happens if I've got a really complicated object? Not only that, but I don't know, did Professor Osborne talk about inheritance at all? Okay, you guys have only seen the tip of the iceberg with object-oriented programming. Where it really gets useful is something called inheritance. We don't have time to go over it because it's actually quite a bit of stuff to go over. But it makes stuff like this really useful. Now I can say I have a person, but it doesn't really make sense for every person on Earth to have a GPA. I can subclass the person to a student and then add in a GPA. So a student has everything that a normal person has, because hopefully you guys are people. Maybe some of you aren't. But it also now has a GPA in it, right? That make sense? Okay. I don't know how much more I have to go over. Oh, yeah, there's a bit more actually. Okay, let's move on. So now we've created two member functions here. Now remember back slides way up when I was saying person Alec, and then I was saying, yeah, sorry.
So when you do the functions in there, like, is it more common to put everything, or the declaring it and
Oh, all in line right there in class?
Right.
No, it's never done that way.
okay.
It's always, always, always done like you guys did on homework, where you say std string, toString, open close parentheses, semicolon, and then your implementation in real C++ code always goes in the CPP file. And it's on big projects, it must be that way. You just can't get away. In C++, you can't get away with doing it like this. Now, should the language have been designed that way? No, of course not. Like, it's way easier to read like this, right? It's so much easier to read where you just open the brace right there and implement it. And that's what Java does, C# does, every language that I know of that's not ancient does. But in C++, it's always done that way. Okay, so I used to have code like this, right? I created a person Alec, and then I set a whole bunch of member variables to values on Alec. Now, here's a problem. What if I create a person Alec, and when I'm using the code, all I set is the name, and then I forget to set the rest of it? That doesn't really make sense to have. It doesn't make sense to have a person that only has part of their data filled in. I don't want that to be a thing that my user of my code can accidentally create. I want them to be forced to provide everything that my class needs up front. And there's like, a whole bunch of lines of code here that I don't really think I need, because I'm gonna have to type this in every single time, right? So here's my sales pitch. You can take these 4 lines of code, and you can turn them into 1. And the way that I would like to do that is just to pass in the data that is needed for this object right there where the arrow is. And if you call now, you can get this too. They're called constructors, right? You guys have seen these. So let's go over what's actually happening here. So the closest analogy that I could find to this in database land was not null. So if you set one of these columns to not null in the database, you cannot create a row without giving it data. So it just won't be created for you. it'll say like, no, you can't do this. I can't have a null attribute here. You need to give me everything I need for this row. You need to give me the name, the age, and the GPA, and then I'll create a row for you. So we're going to do the exact same thing in C++. This, the first line here, is a constructor. I got a decent amount of confusion on this. What's hurting people's brains? Just everything in general. It's a lot of material. But you guys do have tests coming on. Yeah?
How come there's only a pointer on character?
Sorry?
How come there's only a pointer on character?
Because remember C doesn't have strings in it. It doesn't have std strings. So I used a char array because that's the best that C has for strings. Because remember that a string is an n-length character array, right? It's a whole bunch of characters one after another in memory. But let's say that you're asking for user input. I don't really know how many characters were entered. So instead, I'm going to go put these characters off in memory somewhere on the heap. And then I'm just going to get a pointer to the first one. And now I've got a char star, which is C's version of string. This is how strings were done in C. And like I said, it's like the cause of probably the more than 50% of security breaches in code is using these gross strings. Yeah?
I'm still confused on like what goes inside the constructor to make it work.
So you mean this stuff right here?
The code inside the brackets.
Okay, let's look back up at, not the shampoo guy, but let's look at this. I create a person called Steven right here, right? Right here, when it's done running this line of code, it's just filled with garbage. It's filled with whatever happened to have been in memory before I created it, which is just total garbage to me. I don't know what it is. Then I have to go through, every single time I create one of these, I have to give it a name, I have to give it an age, and I have to give it a GPA. Every time I create one of these, I'm going to want to do that. So they formalized this idea, rather than leaving it hanging like it would be in C. Like in C, you'd have this kind of code. Rather than just kind of leave you hanging there and you have to write a whole bunch of lines of, it's called boilerplate, it's just junk code. They formalized the idea into constructors. And a constructor, you can think of it like a function. It behaves similarly in that it's a black box, but this is the only black box that has no return type. There isn't a return. It returns nothing. It doesn't return void, it returns nothing. It doesn't have a return type. But it can still take in n number of arguments. Yeah?
When we're creating our constructor, do we normally use, I guess this would be a C++ question instead of C, but do we normally use person, person? So,
Yeah, that goes back to his question, was would you put the, would you open squiggly brackets right here in the class declaration itself? And the answer is in real code, no. You'd say person, and then open parentheses, and then all this junk, close parentheses, and then the semicolon would go right there where my mouse is. Then off in another file, the CPP file, you'd say person, : person. And then the same junk in the parentheses, then you'd open your squiggly brackets. So it separates the declaration with the implementation. And I don't think you guys need to know what those two words mean. But in real C++, that's how it's done. Good? So a constructor always is the exact same name as the class itself, right? It has to be perfectly exact with the same casing. It can't be lowercase p. It's got to be uppercase. And it returns nothing. But then what's in these parentheses, I can choose those. I can pass in whatever I want. I can pass in an std string. I can pass in a char star, a void star, whatever I wanted to pass in. Whatever junk I want to pass into this constructor. Now the use of this, of course, is now, rather than writing those ugly 4 lines of code, I can write this, person, Steven, and then right there I can just open my parenthesis, and it's expecting them in the right order, so I need to give them the right order. I'm going to give name, then age, then GPA. Has to be in that order, name, age, GPA, because just like a function, that's the order that I declared it. Now this constructor does not return anything. And in fact, the constructor is run after the object is actually created in memory. So the object already exists in memory, filled with garbage. Then your constructor can run. So a constructor for something like this, to get time to go over this, not particularly. Wow, how am I already at 24%? This was fully charged. Probably because I'm running 4 screens. So a constructor, you'd create a constructor right here, right? Person. It would take in all this stuff. Let's just copy and paste it. And then close that. So when this line of code runs right here, it still hasn't set anything within this class value. I've just run my constructor like a regular function. It's got a whole bunch of parameters. Now if I wanted to, it's a member function, remember, so I can access this. I can say this arrow name equals, well, I think what was passed into me is a good thing to set it equal to. Or I could say this arrow age equals age. So this is what a constructor would look like, right? Oops. And this chunk of code in the middle here is still important. Because just because I created a constructor that takes in something called name, something called age, and something called GPA, that has nothing to do with what's in this class. If I scroll down, I've declared these three things right here. What I pass into the constructor has nothing to do with them. I've chosen as the programmer to make some logical link between those. So I pass in a name, an age, and a GPA. But if you notice they're lowercase, that's how they're different. Now, because I've made that logical link as the programmer, while my constructor is running, I'm going to set this object's name equal to be whatever was passed into me. This object's age to be whatever was passed into me. And the same for GPA. That crunching everyone's mind. And this is the kind of stuff that like you really got to practice quite a bit. It's really awkward to use. C++, I remember when I was starting C++, it took me months before like I could do anything at all. And that was just like months of every single day coding. It's a really awkward language. So try really hard to like, keep diagrams in your mind and don't get bogged down in syntax. Because C++ is a really difficult language. And like the best advice I can give you guys for C++ is just keep practicing. Have an awesome weekend, guys.